Hi, period 6. I wanted to give you guys another section of notes today. Um, it actually is, if you're looking back at it, it's page number 4 of lesson 6. We've completed page number 1, page 2 for the most part. I hope you guys are able to follow along with that. We kind of ixnayed exercise 4. And then on page number 3, there's 2 multiple choice questions, but I'm more concerned with, I guess you could say, the third set of questions here, A, B, C, D, E, and F. But more specifically, just A, B, and that's it. Just because in C, D, E, and F, the actual coefficient of the x squared term is larger than 1, which we don't do anymore on the regions. So if you just look at 3, part A says, factor the roots of each of the following. And let me just erase that. Of each of the following equations by factoring. All right, so here's how we factor. We know that we're breaking it really up into 2 binomials, setting them equal to 0. And part A happens to be a perfect square, meaning that 36 is a perfect square. 6 times 6 is 36. Now the negative sign tells me that my signs have to be opposite, and I'll place both in there, the 6's. Okay, now we go ahead and solve, and we have x plus 6 equals 0 and x minus 6 equals 0, and we'll get x equals negative 6 and x equals 6. All right, now those happen to be our zeros, or our factors, and it'll tell us that it crosses the x-axis at negative 6 and 6, and it opens upward. All right, now B is a trinomial that we want to factor into 2 binomials. So if we look at letter B, we'll break this down. And again, we want the factors of 27 that add to 12. So, I mean, that immediately sticks out in my head as 9 and 3. 9 plus 3 is 12. 9 times 3 is 27. They're both positive because we have no negative signs in our equation. And then when we set these equal to 0, x plus 3 equals 0 and x plus 9 equals 0, we should get that x is equal to negative 3 and x is equal to 9, negative 9. Again, those are our zeros. And it just tells us that it crosses the x-axis, and perhaps I should have made it more negative here, at 3 and 9. Opens upward and looks a little something like that. All right, so I guess what you can take from this is factoring the equations will lead to finding your zeros, or your x-intercepts, your solutions. They are all the same thing. All right, now moving on to the last page. Question 4 is the skill you really have to learn. Going forward in math, it's important to be able to graph a quadratic function, find its zeros, and then solve it algebraically. And that's exactly what we'll do in question 4. Now, part A says using the graphing calculator, graph the function. I'll go over to my Desmos, and it's right here. And I plugged in x squared minus 4x minus 5, the equation we're given. And if you look at it, our function looks a little something like that. It's a parabola. Looks like it goes through the point negative 1 on the x-axis and positive 5. And it looks like it has a minimum. And the minimum is located at 2, negative 9. Now, I'll transition back to my graph paper here. And I just saw that it definitely crosses at negative 1. And it definitely crosses at 5. We just said our minimum was 2, negative 9. And from there, we can graph the function. Perhaps my graph wasn't the neatest. We'll rework that a little bit. And there we go. Now, as long as you have, like, really it's 2 points of a line, but on a parabola it's like 3 points. You really want both of your zeros and your minimum or maximum. As long as you have those points accurate, your graph can be a little sloppy and you'd still receive credit. So there's our graph. All right, and those are zeros. I guess you can identify them. That's a 0, that's a 0, and it's -1, 0, and 5, 0. And our minimum here is 2, -9. And when you state your zeros, you can list them as solutions. X is equal to -1. X is equal to 5. You can also just list them as coordinates. Both are acceptable. You can also list them as a solution set. -1, 5. Okay? So either or works. And those are the 3 ways you can list your zeros of a function. Now it says find them algebraically by factoring. Well, let's start with rewriting our function. Y equals x squared minus 4x minus 5. And we know we have a trinomial, and we want to break it down into a binomial. We'll start with x and x. And now you'll notice the connection between the graph and the factoring. Our zeros are -1 and 5. Therefore, our factors will be opposite the zeros we find. So I'll have a +1, +1, and a -5. And now if you FOIL this back out, you realize that you do get the original equation. You do get your -5, and you get your -4x. And now we want to really just set this equal to 0 and solve both of these factors for 0. X plus 1 equals 0, and x minus 5 equals 0. Here we have x equals -1, and here we have x equals 5. Both were the solutions that we found in part B and on our graph in part A. All right, and again, these were our zeros. That's it. That's a very useful tool to be able to calculate the zeros or solutions of a quadratic function. All right, now the next lesson we'll expand on this topic. All right, but for now, just try to take this in, transfer it to your notes, try to learn a little bit, and of course, as usual, contact me if you have any questions. All right, have a good day, guys.